Good day, students. Today I'm going to just help you to revise the concept of electrolysis. I hope you still remember the definition for electrolysis, where we are breaking down either a dilute solution or a molten substance using electricity. Remember, the term lysis in science means breaking down. Because it's electrolysis, we are breaking down using current electricity. Okay, right. So in this question, we are doing the electrolysis of dilute sulfuric acid, and we are using graphite electrodes. The graphite electrodes are inert, chemically inert, meaning to say they are not going to interfere with the process of electrolysis. They are chemically inert and they don't participate in the chemical reaction at all. Okay, so in every electrolysis setup, we're going to have a power source. It's very important for you to note the terminals of our power source. We have a negative terminal and we have a positive terminal. Why am I saying that? Because this terminal is going to be directed to an electrode. The electrode which is connected to the negative terminal, we call it the cathode. Okay, so our cathode is going to be connected to the negative terminal, and if you look at the positive terminal, this one we call it the anode. Okay, and the electrolyte is the liquid which is going to conduct electricity, and then the process is going to be decomposed by that electrical current. So because of that, we now have electrolysis taking place. Okay, right. So we have our electrolyte, which is the liquid where our electrodes are dipped. So we call this one electrolyte. Okay, so it's important for you to remember these terms: electrolyte, electrodes. We have two types. We have the cathode and then we have the anode. Because the cathode is directly connected to the negative terminal, so our cathode will also be negative. Okay, and then our anode is connected to the negative the positive terminal, so our anode will also be positive in nature. Okay, now we are carrying out electrolysis of dilute sulfuric acid. Okay, dilute sulfuric acid. Now, if we analyze the compound dilute sulfuric acid, okay, what are the ions present? Okay, the ions that are present here from sulfuric acid, we have H plus, okay, and we have SO4, 2 minus, and then from the water we have H plus, and then we have OH minus. So these are the 4 ions that are present in dilute sulfuric acid. Okay, so we're going to just do what we call selective discharge of ions here. Because we have 4 ions, we're only supposed to discharge 2. Okay, so what's going to happen in actual sense is we are going to discharge hydrogen. Okay, so this one is going to be discharged. Okay, and when OH is present together with sulfuric acid, the sulfate ion, you're going to find out that is the OH that we discharge. Okay, when you come to A level, you'll be given a data booklet where you can look at the electrode potentials, and then you can actually use the numbers, the figures that are there. But at O level, it's a question of just remembering, okay, that the sulfate ion is never discharged when the OH minus is present. Okay, why are we saying 2 ions are discharged? Because we only have 2 electrodes. We have 4, but we are going to discharge only 2. Okay, right. So the sulfate will remain in solution and the H plus will be discharged. So in essence, do you see that electrolysis of dilute sulfuric acid is actually electrolysis of water? When we are carrying out electrolysis of dilute sulfuric acid, it's actually electrolysis of water, because these ions, remember, were contributed by water, H2O, and then this one comes from sulfuric acid. Okay, right, so what is the next thing here? Okay, unlike charges will attract. Okay, do you see the H plus is positively charged, so it will go to the cathode. Okay, so if you ask a question such as which of these is going to be discharged at the negative, okay, the H plus, this is positive, that's negative. Unlike charges attract, you cannot have OH going to the negative because like charges will repel. All right, so your H plus, okay, the H plus will go to the cathode. Okay, so by the cathode, okay, we are going to have H plus here. Okay, and when H plus reaches the cathode, it's going to be turned to hydrogen. Okay, so you see bubbles of hydrogen by your cathode. Okay, why? The origin is H plus ions, and then you're going to have your hydrogen being discharged by the cathode. And then if you look at the anode, is positively charged. So this OH, this OH will migrate to the anode. So we're going to have OH ion migrating here, and when it reaches here, the OH minus will result in the discharge of oxygen. Okay, there is actually an equation that you're supposed to know, especially if you are doing the extended curriculum of chemistry 0620. You are supposed to be in a position to write the equation for the discharge of the hydroxyl ion to produce oxygen. So as this process is taking place, there will be bubbles produced here, there will be bubbles produced there. Okay, bubbles of hydrogen, bubbles of oxygen. Here's an additional question. Where do you think you would actually witness more bubbles being produced? Think about this. The formula for water is H2O. It has more hydrogen and less oxygen. So obviously, we would expect to have more bubbles being produced for hydrogen, because hydrogen is present in larger quantities when you compare it with the oxygen. So we have hydrogen being produced there and oxygen being produced in the other electrode. Okay, so electrolysis of dilute sulfuric acid is actually electrolysis of water. Okay, in an exam, they could even go on to ask additional questions by asking you, what is the standard test for oxygen? What is the standard test for hydrogen? I hope you still remember the popping sound for hydrogen. Pop, hydrogen, okay? Oxygen, essential for combustion. So oxygen will always relight a glowing splint. I hope this short lesson has actually managed to help you to understand the basics of electrolysis, especially when there is more than two ions present. We are going to practice what we call selective discharge of ions, and when you do that, you'll be in a position to choose the right ions that are discharged. But remember, you're also supposed to look at what will happen if hydrogen is present together with some metallic ions such as magnesium, sodium, and also copper. It's a lesson for another day. Otherwise, that's it for today. Thank you.